Section 2.3 is all about functions. So let's start off with a definition. Your book says a function is a relation in which for each distinct value of the first component of the ordered pairs, there's exactly one value of the second component. I'm going to write myself some notes. So I like to word it, every x has exactly one y. So they're going to give you functions in different ways. They're going to give you a table of numbers, a mapping diagram. Sometimes they'll give you a set. Sometimes they'll give you a graph, an equation. So it depends on what you're looking at, but a lot of the times I ask myself, does every x have exactly one y? You could also think about it as x's cannot repeat. So if they give you a table of numbers or if they give you a set, you can look at your x's, and if they do not repeat, then it is a function. And if they give you a graph, you can use the vertical line test, which we'll talk about in a minute. But if you use the vertical line test and it passes, then yes, it's a function. So let's do an example. This is something that you'll see in your homework, and they're just asking you, is it a function, yes or no? And they give you something called a set. A set is just a list of things. These are just a list of points right here. So if you prefer to write them in a table, you can do that. So I just listed them out in a table. So like this first point, this is saying that the x value of 1 matches with the y value of 2. So I just wrote it in table format. You don't have to do that. But you can see that every x has exactly one y. It has a partner. So, or you could see that the x's do not repeat. So yes, this is a function. They will also ask you in your homework for the domain and range. And domain is going to be all of your x values, and the range is going to be all your y values. So if I look at this function right here, my x values are 1, -2, and 3. I just list those for my domain. And my y values are going to be 2, 4, and you don't have to repeat yourself, so just 2 and 4. Okay, here's another example. So pause the video, write it down, and see if you can tell me yes or no if it's a function, and give me the domain and the range. Okay, this one is not a function because my x's repeat. I can look at the sets and see that my x's repeat. Or if you wrote it out in a table, you can see that this x value of 1 has more than one y value. So that is not a function. And they could still ask you for domain and range. And remember, domain is all of your x values. So the x values are just 1 and 2. And then your range is all of the y values. So that's 1, 2, and 3. You don't need to repeat yourself. Here's another example. Take a minute, look at it, see if you think it's a function, yes or no. Hopefully you saw that there were some x's that repeated, so it is not a function. But if they ask for domain, your domain would be the x values, which are -4 and -2, and your range would be 1 and 0. Number 4 is something called a mapping diagram, but it works the same way. These are your x's over here, and these are your y's over here. So can you tell me, is that a function, yes or no, and give the domain and range? It is a function. Every x has exactly one y. The x's did not repeat. So yes, it's a function. My domain is 4, 6, 7, and -3, and my range 100, 200, and 300. Even if they give you a graph, you could still give the domain and the range. So I have all my x coordinates, I have all my y coordinates, domain are x coordinates, range are the y coordinates. So you could still list out the domain and range. So my domain would be -1, 0, 1, and 4, range -3, -1, 1, and 2. And it is a function because my x's do not repeat, which means it's going to pass the vertical line test. Here's another example. I have to decide if it's a function, yes or no, and I'm going to use the vertical line test. This one is not a function. It fails the vertical line test. What that means is I can draw a vertical line anywhere I want. So I just randomly drew this red vertical line here, and it hits the graph in more than one spot. So if it hits the graph in more than one spot, it fails. So here I can see it hits in 2 spots, or I could have drawn a vertical line over here. It doesn't matter where I draw my vertical line, it hits that graph in more than one spot. So that means no, it's not a function. It also means that the x's repeat. So if I draw this vertical line right here and it hits the graph right here at this point at 3, 4, and it hits at this point 3, -4, you can see that that means that the x's repeat. So no, it is not a function. In my next example, do you think this is a function? Yes or no? Yes, it is a function. If I draw a vertical line anywhere throughout that graph, it only hits in one point. Each of those vertical lines only hits the graph in one point, so it is a function. They also asked me to give the domain and the range. Domain are the x values, which are found on the x-axis, and the x-axis goes left and right. So I want to know how far left this graph goes and how far right this graph goes. So see these arrows on the end? It goes forever to the left and it goes forever to the right. So on the far left of the x-axis, that's going to be -infinity, and to the far right, that's going to be +infinity. This graph goes on forever. It covers all real numbers from -infinity to +infinity. Last year, maybe you got to write all real numbers for domain, but this is how you write it in interval notation. It's saying it goes forever to the left and forever to the right. So if you went forever to the left, that'd be -infinity, and forever to the right, that'd be +infinity. For the range is the y values. So I'm thinking about the y-axis. The y-axis goes up and down. So I want to think about my lowest value on my graph and my highest value. So once again, if I look at my graph, I got these arrows here. That arrow is going forever up, and this arrow down here is going forever down. So it's going down forever, up forever. So it's all real numbers again. So instead of writing all real numbers, this is how you would write it, from -infinity to +infinity. Let's look at the domain and range on this one. First of all, is it a function? Yes or no? Does it pass the vertical line test? Yes, it does. It does pass the vertical line test. If I drew a vertical line anywhere throughout this graph, it would only touch the graph in one spot. So yes, it is a function. Now let's think about domain and range. Okay, domain are your x values, so you're thinking about the x-axis. You're thinking about left to right. So these arrows here are saying it goes forever to the left and forever to the right. So it's forever on the left, forever to the right, so it's -infinity to +infinity. Range is the y values, so you're thinking about the y-axis. The y-axis goes up and down. So you want the highest point and the lowest point that this graph goes to. So this lowest point is right here. So on the y-axis, that's -3. So the lowest point is -3, but the highest point, these arrows are saying that this graph goes up forever. It doesn't stop. It goes up forever. So my lowest point is -3, and my highest point, it doesn't have a highest point. It goes on forever, so I'm going to put infinity. Notice I put brackets around my -3 because it's including -3, but you can never include infinity. You can't reach infinity, so you put parentheses around either infinity or -infinity. But if it includes a number, if it stops there, you can put a bracket around it. So here's your answer. -3 to infinity with a bracket around -3 and parentheses around infinity. If they give you an equation and ask you to find domain and range, these are a little trickier. You could set up a t-chart and see if you could get your x's to repeat. You could put anything you want in for x, or you could also just graph it. If you're going to make a t-chart, like I said, you can put anything you want in for x and see if you'll get them to repeat, but you won't. But you can keep trying numbers if you want. Here, I'm just going to plug in a few. And you can keep going. Or, I don't know if you know, it's just a straight line. So picture that. It's a linear function. Y-intercept's 4, slope is 1. So I'm picturing that in my head. If I start at 4 and go up 1 over 1, up 1 over 1, it's just a straight line. If you have a graphing calculator, you could graph it. If you don't have a graphing calculator, you could use desmos.com. And if you can visualize it, you can see if it passes the vertical line test. So yes, this is a function, and domain and range are both all real numbers. I'm actually going to stop my video here, and we'll finish up on the second video.